All right, if you need to get the top of the notes filled in, please go ahead and look. This is your Unit 7 Similarity Notes video of the examples. Okay, so if you need to pause, fill in these notes, you can go ahead and do that. I'm going to start with example 1. All right, example 1 right here says a photograph that is 8 inches wide and 5 inches high is enlarged to a poster, so it's getting bigger. That's 2 foot wide and 1.25 feet high. What is the ratio of the width of the photo to the width of the poster? So notice we're comparing width to width, and it's width of the photo compared to width of the poster. The order of that is really important because when you do your ratio, you're going to do it in order of the way it says. So what comes first, like the width of the photo, that's 8 inches. That's going to go on top of my fraction, 8 inches. Compared to, this is a ratio, so we're comparing two quantities, to the width of the poster, which is 2 feet. There's a little issue here, though. You cannot have feet and inches when you're comparing. You can't compare apples and oranges, is the saying. So if we have feet and inches, sorry if I go out of zoom, that's a problem. So we're going to change this 2 feet into inches, because that's the easier of the two. So I'm going to do 2 feet times 12 inches to equal 24 inches. Okay, that's what I'm going to put on the bottom. So 8 over 24 is now our ratio that we're comparing. We can reduce this, and we should reduce this. So we're going to reduce 8 fits into 8 and into 24. So we divide the top and the bottom by 8. And then we end up getting 1 over 3. Now, for this problem, the label does not matter totally. What it's really saying, because we said width of photo to width of poster, here's the width of the photo compared to the width of the poster. What it's saying is the poster is 3 times bigger than the width of the photo. So for every 1 inch you have in a photo, you have 3 inches in the poster. And that would be your final answer. We don't have to touch the height because it didn't ask to, it just asked for the width. Okay, example 2 is another topic. It says unit rates. Unit rates are things that have 1 on the bottom. So I'll give you an example of that to start. So let's say you're going down the road and you're traveling 50 miles per hour. 50 miles per hour is a unit rate. What it's really saying is 50 miles in 1 hour. So in 1 hour's time, I can go 50 miles. So it is a unit rate because there is a 1 on the bottom. We don't like to say 50 miles per 3 hours. We like to say miles per 1 hour. So let's look at an example. Store, a sign reads 6 apples for $1.50. Okay, if you're like me, I want to know if I'm getting a good deal, so I need to find out, either the cost per apple or how many I could buy with $1 or that kind of thing. It says write a rate for how much 1 apple costs. Okay, so let's kind of just figure out how much does 1 apple cost. Notice it says write a rate. So that's going to change a little bit when we say write a rate. But let's figure out 1 apple. Well, if I have for how much 1 apple costs, remember we said the 1 goes on bottom? I'm going to put 1 apple on bottom. And I'm going to divide it. Oh, sorry, I'm going to put 6 apples on bottom. 6 apples on bottom. And I'm going to divide it by, or I'm going to put 150 on the top. So I have 150 divided by 6. Now, if I want to know how much 1 apple costs, I could set up a proportion. I could set up another fraction that's equal to this one. And I can put here, let's see, do we know how much 1 apple costs? I'm not sure yet, so I'm going to put an X here. And then I'm going to put a 1 for 1 apple here. So if it was $1.50 for 6, I want to know how many is it for 1 apple. Another point to notice is apples are on bottom and the money is on top. Now, if you get a proportion like this is 2 ratios compared to each other, you cross multiply. So I'm going to do 150 times 1, and that's going to give me $1.50. I'm going to do 6 apples times X. That's going to give me 6X. All right, then next step is I'm going to divide by 6, and divide by 6, and $1.50 divided by 6 is going to give me 25 cents, and that's per one apple. This is a rate because it's 25 cents per apple. Look at the next question. Write a rate for how many apples you could buy if you had $1. So now instead of having one apple on bottom, I want $1 on bottom. How many apples could you buy if you had $1? Well, just looking at this, it's 25 cents an apple. I know it's going to be 25, 50, 75, oh, we're up to $1. 4 of them. 4 apples for $1. But let's see how we can do that with a rate. See if we get the same answer. We'll set it up just like we did above. For this one, though, money is going on bottom because we're going to have this proportion like this. And I know I'm going to have $1 on bottom and some amount of apples, I don't know. And my original proportion was $1.50 and 6. We will again cross multiply. 6 times 1 is 6. $1.50 times x equals $1.50x. And then you divide both sides by $1.50. Okay, if we divide this out, then we get x equals 4. Remember, that's 4 apples, so if we want to make that into a rate, the question says write a rate, then I'm going to put 4 apples per $1. So what do you notice about the rates? Is $1, all 3 of these, even my example, there's 1 on the bottom. 1 hour, 1 apple, $1. Okay, the unit rate has a denominator of 1. Okay, this is example 2. You'll need to know the stuff from the previous notes to do example 2. What the previous notes state, though, is to know if these are equal, which we know they're equal. It says it's equal. If we do the cross product, x times 6, so that would be 6x, would be equal to y times 5, or 5y. That always has to be true. Whatever you cross here, whatever we have down here has to say the same thing. We always need a 6 next to an x and a y next to a 5. Okay, so if we look at this, it says, complete each statement, 6x. Well, if we got 6x, well, it has to go over here. That has to be equal to 5y, because the 5 has to go with y. What if they start with y over x? What this is asking is for me to do a proportion and put a fraction here. If I look up here, the y has to go with the 5. So y, if I cross, the 5's got to go on the bottom. And if I cross here, the x has to go with the 6. And the final example, if you have x and 5, make a proportion. And then we cross multiply. What had to go with the x? It's the 6. And when cross x, 6 has to go down here. And the y had to go with the 5. So when we cross, y goes here. So once again, we get 6x equals 5y. For example number 3, I'm going to do an A and B, and I'm going to leave C and D for you to do. So for A, we just cross multiply to solve these proportions, and I get 7 times x if I cross here. So I'm going to get 7x is equal to 5 times 12. And 5 times 12 is 60. Sorry about the focus issues. I'm not sure what's going on exactly. Try that. And then what I'm going to do is I'm going to divide both sides by 7. For that, we get, and then we get x equals 8.6. For B, we're going to cross multiply also. The big deal here is you got to distribute the 4 to both of these when we cross multiply. So we get 8 times y is 8y equals 4 times y plus 3. And then I need to distribute that. I got to multiply this 4 by everything here. So it becomes 8y equals 4y plus 12 minus 4y from both sides. We get down to 4y equals 12. Divide by 4, divide by 4, and y equals 3. Okay, for example number 4, we're going to use what's called a scale factor down here, which says 1 inch equals 16 feet. What that's saying is 1 inch on this drawing So 1 inch is equal to 16 feet in real life. This is the start of our proportion. This is our ratio that we're going to use to figure out these two wall lengths. Now, what trips students up usually is they try to do this all in one. You can only do one length at a time. So when I set up my proportion, sorry about that, I'm going to do 1 inch over 16 feet. Okay, 1 inch over 16 feet. And then I need a second proportion. Inches have to go on top. Well, I'm going to do this ball first. We got 1.5 inches on the drawing. And then in real life, we don't know what it is. It's x. So again, we cross multiply. We do 1 times x is x. 16 times 1.5 would equal 24. So in real life, we get x equals 24 feet. That's this dimension, so that's a 24. Now we got to go and do the other wall, which is 0.75 inches. So I'm going to set up the same proportion to start, 1 inch over 16 feet, because that is my scale factor, equals, but now I'm going to put 0.75 on top, over x. 1 times x is x, equals 16 times 0.75 is 12. So if you look here, then this side would be 12. If we ask you what the dimensions are, you would say this room is 24 feet by 12 feet. That would be your actual official answer. Okay, if you have any other additional questions on these problems, make sure to ask.